We now discuss the solution of a problem from the section Integral Calculus. This question is on the definite integral. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, if Bn is equal to integral 0 to pi by 2 cos square nx by sin x dx, where n belongs to the set of natural numbers, then we are given four options. Option A, b3 minus b2, b4 minus b3, b5 minus b4 are in an arithmetic progression with common difference minus 2. Option B, 1 by b3 minus b2, 1 by b4 minus b3, 1 by b5 minus b4 are in an arithmetic progression with common difference 2. Option C, b3 minus b2, b4 minus b3, b5 minus b4 are in a geometric progression. Option D, 1 by b3 minus b2, 1 by b4 minus b3, 1 by b5 minus b4 are in an arithmetic progression with common difference minus 2. We are given Bn is equal to integral 0 to pi by 2 cos square nx by sin x dx, where n belongs to the set of natural numbers. So we have to, from Bn, we have to compute b3 minus b2, b4 minus b3, b5 minus b4, and thereby, discuss the nature of these numbers, whether they are in AP or the reciprocals are in AP with a common difference 2, or whether the numbers are in GP or their reciprocals are in AP with common difference minus 2. So these are the things which we have to discuss. So for this, to get b3 minus b2, b4 minus b3, b5 minus b4, the difference of the indices is 1. So we compute bn minus bn minus 1, where n belongs to n. We now discuss the solution of the problem in detail. We have bn and we compute now bn minus 1 is equal to, bn is integral 0 to pi by 2 cos square nx by sin x dx, minus bn minus 1 is integral 0 to pi by 2 cos square n minus 1 x sin x dx. Agreed? So this is equal to integral 0 to pi by 2 of cos square nx minus cos square n minus 1x by sin x with respect to x. Now, we do not have a formula for this cos square a minus cos square b, but we have a formula for sin square a minus sin square b. So what we do is, for cos square nx, we write 1 minus cos square nx, 1 minus sin square nx, minus, for cos square n minus 1x, we write 1 minus sin square n minus 1x, and 1 cancels, and we get integral 0 to pi by 2 sin square n minus 1x minus sin square nx by sin x dx. Now recall the formula, sin square a minus sin square b is equal to sin of a plus b into sin of a minus b. So this is equal to integral 0 to pi by 2 sin of the sum of these two, that is n minus 1x plus nx, multiplied by sin of the difference n minus 1 times x minus nx. You have to write. So that is equal to integral 0 to pi by 2 sin of the sum, sin of the difference by sin x dx. Now here nx cancels and we have a minus x. Sin of minus x we have. For here 2n minus 1 times of x. So integral 0 to pi by 2 sin of 2n minus 1 times x, sin of minus x by sin x dx. Sin of minus x is minus sin x, keep a minus here, sin x cancels. So that will be equal to minus integral 0 to pi by 2 sine of 2n minus 1 x dx. We continue in the next slide. We have bn minus bn minus 1 is equal to what we have seen in the earlier slide, minus integral 0 to pi by 2 sine of 2n minus 1 times x with respect to x. Integrating, so the integral is minus cos x, there is a minus is already there, so that is cos of 2n minus 1x by 2n minus 1 to be evaluated from x is equal to 0 to x is equal to pi by 2. So 1 by 2n minus 1 take common, and for the upper limit cos of 2n minus 1 pi by 2, for the lower limit cos of 0, cos 0 is 1, and cos of 2n minus 1 pi by 2, where n is a natural number, that means pi by 2, 3 pi by 2, 5 pi by 2, so on and so forth, cos values are 0. So you are left with, the answer is minus 1 by 2n minus 1. So bn minus 1 is minus 1 by 2n minus 1, where n belongs to the set of natural numbers. Now suppose I take the reciprocal, 1 by bn minus 1, then that will be minus 2n minus 1, n belongs to n, and this is in arithmetic progression. Agreed? So that means these are arithmetic progression. So take the values. So we are interested in what? N is equal to 3, n is equal to 4, n is equal to 5. So for n is equal to 3, 4, 5, for 3, 1 by b3 minus b2 is equal to minus, for n is equal to 3, 2n minus 1 is minus 5. So also for 4 it is minus 7. For n is equal to 5 it is minus 9. So what are they? They are in an arithmetic progression with a common difference, that is minus 7 minus of minus 5, that is minus 2. So these are 1 by b3 minus b2, 1 by b4 minus b3, 1 by b5 minus b4 are in an arithmetic progression with common difference minus 2. That's our answer. So let's look at our options. Our answer, that these are in an arithmetic progression with common difference minus 2, appears against option D. Yes. Therefore, the answer to this question is option D. That is the detailed discussion of the solution of the problem on definite integral combined with progressions. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.